Hi, welcome to Michaela Minkler, Secondary Math and Science. In my regular entire year, sixth grade math guided notes, I separate one-step inequalities in a day of multiplication and division and a day of addition and subtraction. So this is just combining it all into one. Maybe you don't have time to split it up or you just prefer to do it all in one day. So this is very similar to solving one-step equations. You follow the same steps in the beginning, and then there's something a little different towards the end that we are going to go over. So your first step is to undo the addition and subtraction with inverse operations to zero out the constant. So for example, if you have x plus 3 is greater than 7. To zero out the constant, you would do the inverse of addition, which is subtraction. So you have x is greater than 4. Or if your operation that's happening in your inequality is multiplication or division, you will do the inverse operation to eliminate the coefficient. That's the number in front of the variable. So for example, if you had 2x is greater than 8, the inverse of multiplication is division. So I get x is greater than 4. So I like to go back and explain that the reason this works is you end up having 1x. 2 divided by 2 is 1. 1 times x is 1 times x equals x, just like 3 times 1 would equal 3. So that's why that works. So then you need to verify your solution by substituting it back. So this is really important when it comes to inequalities. You are not going to substitute back 4 for this one. You need to find x is greater than 4. You need to find a number that is greater than 4. It doesn't matter what the number is, it just has to be greater than 4. So I'm going to choose 5. 5 plus 3, is that greater than 7? Yes, it is. So my answer is correct. I am actually going to change this right here for a certain purpose. So this is x is greater than or equal to 4. So I actually can choose 4 in this case. So is 2 times 4 greater than or equal to 8? It's equal to 8. So this is a true statement. So this is correct. So if you are multiplying or dividing by a negative when you are solving, you need to make sure that you flip the inequality. And I'll show that in some of the examples below. So number 1 says solve the inequality and graph the solution. So the inverse operation of subtraction is addition. So I have x is greater than 16. I need to go back and verify this solution. Pick a number greater than 16. I'm just going to do 20. So is 16 greater than 12? Yes. I'm going to have an open circle. And my arrow needs to point towards all the numbers greater than 16. Solve the inequality and graph the solution. 6 is being added to x, so I'm going to subtract 6. I need to remember my integer rules. Keep, change, change. So x is greater than or equal to negative 19. I'm just going to pick 0. So it's negative 13 less than or equal to 6 plus 0. Yes, it is. This is a closed circle. And it needs to be numbers greater than or equal to negative 19. Now, you can rewrite this. Just make sure that your inequality, in this case, the mouth is facing the x. I still want the mouth to face the x. Some people will talk about how this is going this way, so the arrow is going this way. This only works if x is on the left, so you need to rewrite it if you're going to do that. All right, x is being divided by 12, so we are going to multiply. Negative times a positive is a negative. And this number is not negative, so we are not flipping the inequality sign. I need to pick a number less than negative 60. I'm just going to do something that can be easily divisible by 12. Let's do negative 72 divided by 12. That's oops. It's negative 6. So the statement is true. Open circle. All right, x is being multiplied by negative 12, so I'm going to divide. We are dividing by negative numbers, so I need to flip this. I'm just going to simplify this using the greatest common factor. So negative 2/3, also known as 0.6 repeating. I am going to pick a number that is less than negative 2/3. Let's do negative 1. So negative 12 times negative 1, is that greater than or equal to 8? It's positive 12 is greater than or equal to 8. That is correct. So this closed circle. All right, x is being added to 27. I'm going to subtract 27. Keep, change, change. So I'm going to add these. X is greater than negative 172. I'm just going to pick 0. It's just easy. Try to think of numbers that are easy. So is 27 greater than negative 145? It is. X is being divided by 3, so I'm going to multiply by 3. Because this number is not negative, I do not flip the sign. Oops. Number greater than negative 12. Let's just do 12. That's easy. Is 4 greater than or equal to -4? Yes. Close circle here. All right, I'm going to divide by -8. Because I'm dividing by a negative, I'm flipping the sign. Number greater than -8 is 0. So 64, is that greater than -8 times 0? 64 is greater than 0. Open circle. And again, you can rewrite this to help you with graphing. All right, I'm going to do keep, change first. So x is being added to 78. So I'm going to subtract 78. What's a number less than or equal to 65? 0 is an easy one. So 0 minus -78. Is that less than or equal to 143? Keep, change, 78. Yes, that is true. Close circle. All right, thank you so much for watching. I appreciate it. Just to let you know, all my sixth grade math guided notes have a YouTube video to go with it. This is helpful if you want to do a flipped classroom or if you have a student that is absent. You can post it in Google Classroom and they can watch it from home, or they can just watch it on their own time once they get better, or maybe they're out for a sporting event. It was really helpful when I was on maternity leave. It was there for my long-term sub to be able to watch to see how to teach it, or if she didn't feel comfortable, she could just have the students watch the video. I appreciate it so much, and I'm so excited that you have joined my email list.